In the previous session, we have solved 4 problems. This is the last problem that we have seen. So let us continue this problems. Okay, you can see the fifth problem. There is a circular conductor of 1 centimeter radius. You can see. Okay, there is a cylinder kind of a structure which is of 1 centimeter in radius. It has a field H, magnetic field intensity H is given in the question in Fi direction. So H is given to you. Till now we have found H value. Now H is already given to you. So what is A? Here A is mentioned. In terms of sine and cos, you have A value, and R naught is the radius of the conductor. So you can see I have mentioned here R naught, which is the radius of the conductor. We need to calculate the total current. So till now we have used the Ampere circuital law, wherein current was given to you, some DL was given to you, or you have found the different angles and you have found H. Now using Ampere's law, H is given in the question. You need to find what is current. Okay, so let us proceed. Just try to recall in the theory how we go for Ampere circuital law. If I take any conductor, straight wire, surrounding that wire we consider a closed path. Okay, and applications of Ampere's law we have seen in coaxial cable, straight conductor, then a cylindrical conductor, solenoid and toroid. Okay, so if I take this as one application of Ampere's law, this is one cylinder given wherein R naught is the radius of that conductor. Okay, we need to identify from the field value what is the total current I. So for that I need to consider the closed circular path. So you can see over this perimeter I have taken one dotted line circle. This indicates what? The closed path. Ideally I should have taken outside this conductor. Okay, but however I have taken just touching this perimeter so that the radius is given already in the question 1 centimeter. So I can utilize that. Okay, otherwise in theory we have seen the circular path is considered, there are different possibilities inside, outside. So we have seen different applications. So I'm here taking the closed circular path, just touching the perimeter of this cylinder. Now let us move to the calculation. We know that Ampere circuital law is given by integration, line integral of HDL equals to I. So we need current I. It's a very straightforward question. H is given to you. So what is this line integral? The range. We know that for a closed path, the total angle subtended will be 2 pi. So that's why if I take this circular path divided into many smaller lengths, if I take all together, I have to, consider the complete angle that is subtended in the circle, that is 2 pi. So that's why the range is between 0 to 2 pi, and H is given to you. This value is H. I have substituted. You can observe wherever A value is there in the given H, I have substituted in turn A as pi by 2 R naught. Okay, and DL I have kept it as it is. And in the theory classes we have seen, if this is that arc length DL, this is your radius R, this is your angle D phi. So what is DL? Arc by radius is equals to angle. So with that we will get R D phi as the DL value. So I have taken that, and A phi dot A phi will be equal to 1. I dot I, J dot J, K dot K is equals to 1. So further you can see 1 by R naught, and whatever this pi by 2 R naught whole square, I have simplified that here. And the sign of, when I substitute for small a value, I will get pi by 2. So sine pi by 2 will be 1. And see, in the denominator and numerator, both I have considered R naught, because whatever circular path we are considering, it is just touching the perimeter of the cylinder, and the radius of the cylinder is R naught, which is equals to R we can consider. So substituting that, these two will cancel. You will get only sine pi by 2. And in the second term, it is cos of pi by 2. If I simplify, you can see in the given question, it is AR. it is AR. Instead of A, I'm substituting pi by 2 R naught, and instead of R, it is R naught. Substituting these two, only the sine term will remain. Cos will vanish. So that's why the second term minus is not written here. Further simple integration, simplification, 0 to 2 pi. You have this pi square, then R equals to R naught square. This is a 2 square. So it is denominator of the denominator has come to the numerator. You have pi square, then sine of pi by 2, a phi, r d phi. So if you simplify this further, you will get this 4 by pi square, r naught square, because this also I have considered as r equals to r naught. So it will be r naught square, and this r naught is given to you. What is the radius? It is given in the question 1 centimeter. So I'm substituting that 1 centimeter, that is 10 to the power of minus 2 whole square into d pi. So all these are the numbers. So you can calculate that what is the value, and integration is with respect to d phi. So integration of d phi is 5. Substitute the limits 2 pi minus 0. If I simplify this, you will get the current as 8 by pi into 10 raised to minus 4. I have got some value. Okay. So this is moreover, how to find the current. H is given to you using the Ampere circuital law. So H is given, I is asked. So here nowhere they have mentioned in the question use Ampere circuital law. Nowhere it is mentioned. It is understood that this is in your module 3, the second half, the problems you are finding the current means you are using the Ampere's law. अगर magnetic field find करना होता तो we would have either opted Biot-Savart's law or Ampere's law. Both possibilities exist. Hope it is clear to you. If any doubts, please stop me. Now, in cylindrical coordinates, let us move to the next problem. This is in the cylindrical coordinates. They have given the value of B. B is magnetic flux density. H is a magnetic field intensity, and we know that B equals to mu naught times H. B is mu naught times H. So B is given. You can see the symbol T indicates it is in Tesla, and the direction is also specified, means B is a vector quantity. Determine the magnetic flux crossing the plane surface defined by R and Z. The ranges for R and Z are given to you. In the topic magnetic flux and magnetic flux density, we have seen this equation. Phi equals to surface integral of closed surface integral of B dot ds. Even while dealing with the magnetic scalar and vector potentials, we have come across this equation, wherein finally we derived del dot B equals to 0. If you remember in the class, we have solved this. So what is this phi? Phi is the magnetic flux. So question में क्या है? Given is B, flux you need to find. So flux and B, how they are related? B equals to flux density is कितना flux cross हो रहा है per area, and area being perpendicular. This is how we define magnetic flux density, and B is given to you. If you take the product of B into A, you will get the flux. Since here the total flux we need and the area is across the ds, you know the range is given for R and Z. It is not XYZ. It is not a rectangular coordinate system. It is cylindrical coordinate system given. So for R and Z, range is given, and B is in the direction of A phi. You know, always the flux density will be perpendicular. It will be always the third coordinate. So with this background, this is the formula we have to use for flux. To find the flux phi, we will use this formula. You can see this is surface integral. So दो integrals आएंगे. Range, one range is for R, one range is for Z. That is what is given to you even in the question. And the substitution of B. I have substituted the given B. And what is a ds? Okay. Again in the class as a note, I have given for 3 different coordinates systems, spherical, cylindrical, and rectangular. What is this area ds? as a note I have given, please recall in the classes we have done, probably in your notes. If you just turn the pages back, you will find this. So ds is taken as for a5 direction, because b is a given in a5, so obviously a5 dot a5 होगा हमारे पास. It's a dot product. Okay, so ds ka obviously the area is with respect to the r and the z coordinates. So it is a dr and dz. So please turn the pages and check what is ds in a cylindrical coordinate system. Actually, you come across ds in r, ds phi, and ds z. I think three different equations I have given you in the class, out of which this one you have to use, ds phi. Okay, so it is dr dz into a phi, and obviously agar dz hai to it will cover dr and d phi. Other two coordinates it will cover. So taking this, now further we need to go for integration calculation. See, I have taken this r integration with respect to this and this. Remaining, you can see I have clubbed this integration with these r terms. And the z integration I have clubbed with only dz. No other z terms are there. And what is d phi dot a phi dot a phi? It is equals to 1. So further, what is the integration of 1 by r? It is log of x, right? 1 by x is log x. So if you take that, it will be ln of r. The range is between 0.5 to 2.5. That is given here. R range is given 0.5 to 2.5. Z range is 0 to 2. So I am considering those. What is the integration of dz? It is z. So solve this. I have not done that. What you have to do, it is ln of 2.5 minus ln of 0.5, which is nothing but ln a by using the formula. See, 2.5 by 0.5, what you will get? 0.05 probably. Check the value. Ln of that value, what you get, into 4. So if you do that, I have got 6.44, and this is a magnetic flux. Okay, it is something like your electric flux. So magnetic flux, it is measured in Webers, and H is measured in Webers per meter or amperes per meter. So formula based है problem, direct है, direct substitution. Just ये formula आपको याद रखना है, how to find if B is given to you, how to find magnetic flux. Please let me know if any doubts are there. Stop me wherever you feel any doubt. Next question. In a region, R range is given to you. The current density J is given to you. You can see the direction of J is in AZ direction. And whatever current density is given, it involves this R term also. Okay, just for your observations. Now, what is the question? We need to find magnetic field intensity H. J is given to you, current density, H find करना है. H आपको find करना है. J is given to you. So here in the question they have specified using Ampere's law. So आपको ये equation आपको use करना है. You need to find H. H find करने के लिए you require this DL and I from the Ampere's law. So अगर DL तो obviously we can get R range पता है आपको, and it is nothing but, if you take this part DL, this angle is D phi. So you know R into D phi will be DL. That is fine. But what about I? Current is not mentioned in the question. Instead, they have mentioned the current density. But do we have any relationship which relates J and I? Yes, we do have a relation. This equation in the concept current and current density in module 2, we have studied this. J dot ds is equals to I. So इस equation को use करके we can find what is current I. Then we can further substitute it here. So it's again very simple. Direct current नहीं दिए हैं. J is given to you. From J you need to find I. So what I'll do, instead of I'm using this integration of j into ds. So let us consider this RHS first. So I'll solve this RHS and then I'll substitute. So integration of j dot ds is equals to, what is given here? J is in az direction. See, j is given in az direction. Okay. So obviously जब आप ds लोगे, ds भी आपको az ही होना चाहिए. Then only dot product exists. Right? az dot az. Otherwise it will become zero अगर आप कोई और unit vector लेंगे यहाँ पे. So that's a common sense that you need to use. Don't get confused. क्योंकि see, for rectangular coordinate system, 3 different ds equations are there. Okay, that is dx dy, then dy dz and dz dx. Similarly, अगर आप cylindrical लेते हो, again 3 ds will come. एक ds आपको cylindrical coordinates r के लिए होगा, ds phi and ds z. And similarly for spherical 3. So totally 9 different values are there. So which one to choose? So you need to act smartly here. जो भी आपको दिए हैं value, the first term vector value, check its direction. उसका direction जो भी होगा, associated direction you have to use. So accordingly you should use, it is called ds of z you need to consider. If you go for that, it is r into dr into dy. You can just cross check this. I have given you the list of ds and dv's for different coordinate systems. So in that, if you check the list, ds for this cylindrical coordinates in az direction is r into dr into d phi. So I've substituted that. Now taking the dot product. So if you take the dot product, again there are 2 integrals here, one for r and one for phi. I think r range is given in the question. See, 0 to 0.5 is the range given for r. But what about phi? Again, we have to, for Ampere's law, we have to consider a circular path. So phi by default, it will become 0 to 2 pi. See, 0 to 2 pi. What I have done here, I have again separated the integrals. जो भी r के corresponding values हैं, you can see 4.5 तो constant है, आप उसको बाहर रख सकते हो. E raised to minus 2r, one term, and you have r dr. So I can club all these together and put it as one integration, and remaining is only d phi. And what is az dot az? It is equals to 1. So it is, second integration is easier. Integration of d phi is phi, 0 to 2 pi range. Now what about first integration? It is not as simple as it looks. You see this, in the first integration, you have UV formula. What is that? Integration by parts you have to use here. One such problem we have already solved, I guess, while solving Gauss's law, probably, to find del dot d something through the Gauss divergence theorem. Both sides of Gauss divergence theorem, we have already done this kind of problem where integration by parts formula we have used. So one function is e raised to minus 2r, the other function is r. आप देख सकते हो integration is with respect to r. So दो आपको functions हैं यहाँ पे आपके पास in the integration which are dependent on r. Okay, that's why you cannot simply take the integration directly, or you cannot even go for any substitution method. दो अलग अलग functions available हैं आपके पास जो एक ही variable पे dependent है. So for that, use integration by parts. Okay. What I have done, I have clubbed this and 4.5 all together outside, and integration is with respect to this. See, I have not solved the integration directly. I have written UV formula. I have given you the formula. I think I had shared it in your groups. Please go through it. When you apply that formula, I have got this. So I have done that directly. Sorry, I skipped that. Okay, I had done it in the rough paper. So I have substituted this value and range I have kept it. So please do cross verify whether this is correct or not. Okay, what formula I have used and I have got the values are this. You cross verify with your when you solve it whether it is right or not. Further, you substitute what is r. This takes time. Okay, you should be very patient while doing this, because when you apply 0.5, the upper limit one time, you will get some exponential term. You need to calculate using calculator. It will be what? It is simpler, I guess. E raised to minus 2 into 0.5 is 1. So e raised to minus 1 you'll get, divided by minus 4. And this is also 2 into 0.5 is 1, minus 1 minus 1, minus 2. जब आप 0.5 यूज करते हो तो आपको एक टर्म मिलेगा यहाँ पे. बट व्हेन यू सब्स्टिट्यूट 0, डोंट डायरेक्टली मेक एवरीथिंग 0, क्योंकि व्हेन यू
सलमान
टेक
10
दिस,
बज रहे हैं, खाना खाने आओ आप.
so further when you go for the lower limit application, this term may become 0, but the second term do exist. So be careful here. So whatever some numerical value you will get here when you substitute. Yeah, I've taken it here. That I have not solved it because anyhow मुझे at the end substitute करना ही है. So I have taken that directly here. You can see I have taken that directly, and this is equals to I, right? And I is in turn equal to J dot ds. Just the previous page formula I'm recalling, J dot ds. So this value just now we have got, that is I. And what is h into dl? H taking outside. What is the line integral? That is the total circumference. The perimeter is 2 pi r. 2 pi r for the circular path. So it is 2 pi r into h. So h into 2 pi r is equals to 2 pi into 4.5. ये जो star equation है, इसको as it is मैंने लिया है. I have not solved it. Further here I can solve. So 2 pi, everything I have kept it as it is. Further यहाँ पे 2 pi cancel हो जाएंगे. Then 4.5, and this value I have taken it outside. That is 4.5 divided by minus, minus is taken inside. It is 4. Some 1 point something I'll get. So that divided by r. This r I have taken it to the denominator, and this bracket value. When you apply, you can see यहाँ पर एक 1 मिलेगा आपको. Be careful here. When you apply the limits, upper and lower limits, be careful with the r. I have got the h value 0.594. So whatever I have done here, it is again further just mathematics है. आपको substitutions करने हैं. While doing so, please follow each step carefully. Okay, substitutions. Now the next problem. Please stop me if you feel anywhere you find any doubt. A current filament of 5 amperes in the direction of AY, it is parallel to y-axis at x equals to 2 meters, z equals to minus 2 meters. So एक conductor है, उसका placement का position values आपको x and z के form में दिए, and it is parallel to y-axis. See, I have done it here. If you move x in 2 units, y there is no moment because y parallel है z. You have to take a minus 2. So below you have to go minus 2. I have moved it. So somewhere here that current filament exists. Okay, conductor is kept parallel to y-axis. This is given. You need to find h at the origin. So यहाँ पर आपको origin पे h का value find करना है. Here important thing is, first thing, which concept to use in order to find h, and second thing, how to mark where the filament is. These two things are there. So already marking we have done. You can see there is a origin here, and the distance is the points are given 2, 0, minus 2. 0, y I have taken 0, the middle term, y parallel to y-axis, so I have taken it as 0. Now obviously which formula we have to use, that is important here. It is along this y-axis, so it is infinite. Considering that, instead of going for dh, what I'm doing for the infinite conductor, what is the formula? to find the magnetic field intensity, H. H equals to I by 2 pi r in AR direction. I think it is not AR, it is A pi direction, right? So formula I think कुछ गड़बड़ की है मैंने. No, you just check this formula once, okay? Whether it is AR or A pi. Filament current is in this direction. Okay, fine. Now, moving to the calculations. So using the formula, please check this formula, okay, once. Using this formula, current is given to you. This distance is unknown to you. आपको H find करना है, R is unknown to you and unit vector is unknown to you. How to find R? So R is what? The separation between, suppose यहाँ पर आपका current element है, this is your conductor, this is your point, ये distance आपका R होगा. So that distance I have calculated, square root of the points. You can take distance formula. I have got it root 8. That is nothing but 2 root 2. I have got it. And how can you find the unit vector? This AR is your unit vector in the direction. अगर ये आपका conductor है, यहाँ पे DL है, this is your point P by Savart's law. So this distance is R and towards point P you are finding H. So this is your AR. Okay, that AR I have taken it here, but when you calculate at the end using cylindrical coordinates, you'll get A phi. Fine. So what is AR? Whatever position vector is there, that we need to calculate divided by the magnitude. So what is the position vector? So points आपके पास हैं. I have symbolically written here I and F. You can see the direction I have mentioned for AR is like this, क्योंकि यहाँ पे हमको H चाहिए. And this is your DL value. If I consider that initial, final, final minus initial. So 0 minus 2, 0 minus 0, 0 minus of minus 2. So I have taken that and y का तो कोई term आएगा नहीं क्योंकि filament आपका y को parallel है. So x and z terms exist for R. So this is position vector. Magnitude already आपने calculate किया है. What is AR? You can find it. So once AR is known to you, use the formula H equals to I by 2 pi R into AR. So I have kept it blank. Yeah, it's not having the calculator that time. So please put whatever answer you get. Okay, just put that in amperes per meter. Fine. Let me take one last problem. Okay, with that I'll stop it. It's again simple. This is the problem for coaxial cable. Remember, I think some 4 regions they had calculated as an application of Ampere's law. Okay, a long 1.5 hour class we have conducted for this, taking different regions. So find the magnetic field at a point P. Okay, point है, इस point पे आपको H find करना है. If the current through the coaxial cable is 6 amperes, so current is given to you. And the current direction is along positive z-axis and the different radii are given to you. Remember, when we have taken the coaxial cable, just let me recall very quickly. Inner radius is A. If you see, this is the thicker, the outer conductor which is having a thickness. ये radius B है, ये radius C है. Try to recall the theory class. Okay, this is the cylinder I have drawn. It is kept along z-axis and current is also moving. You can see if the current flows is 6 amperes, it is along z-axis. So along the z-axis, the current is flowing. Now, I have located the point P. Point 0, 1, 0, 0 means x axis के towards पे यहाँ से यहाँ तक. Okay? This is your point 0, 1, 0, 0 point. यहाँ पे आपको h find करना है. So आपको अगर theory, if you recall, we have already derived this formula H equals to I by 2 pi R. We had many different regions, okay? But अगर आप P consider कर रहे हो outside, this was one of the the value of H for out of 4 different regions. एक region के लिए ये value हमको आया है H, okay? You try to see the theory where we have got this equation. So we are using this H equals to I by 2 pi R. c square minus r square by c square minus b square. And what is r? जहां पर भी हम circular path लेंगे, blue dotted lines, okay, inner, outer, intermediate, it is that radius. So if you see here, this distance is unknown to us, 0 से यहाँ तक, that is nothing but 0.01 only, क्योंकि only x variation is there. अगर आप distance formula भी use करते हो, center पे आपका 0.000 है, so you can see the distance formula, root of 0.01 square, नहीं बचेगा. So we have got this as 0.01 meter or 10 mm. Why I have converted it to mm? Because in the question ABC everything is given in mm only, so easy for cancellations. So I have converted it to 10 mm. So if we use the formula, h equals to I by 2 pi r, 10 mm divided by into c is 11 mm, r is also in mm, okay, the radius, c square, it is 11 c, b is 9. So this is all given already. न्यूमरेटर भी आपका mm में आएगा, यहाँ पर भी mm में आएगा. So ये आपको botheration नहीं. Okay, this is not this doesn't matter to you because anyhow they get cancelled. So I have calculated this. I have got this 50.113 in A5 direction. You just try to find out ये formula जो है out of 4 different regions, for which region we are using this formula. Okay, means जब हम आप closed loop ले रहे हो, जो circular path है, that circular path where we are considering either here inside or in between A and B or in between B and C or totally outside. 4 different regions where there are possibilities. उसमें से I think it is between B and C as far as I know. So just cross verify that. Okay. It's against direct substitution formula hai. Just looking at the question, don't get afraid directly. These many values are there, how to find. Please recall the theory. अगर theory concepts के formula, theory concepts clear हैं आपके, तो आप problems easily solve कर सकते हैं. And the last question, which is a homework week. In the similar line, try to do this. I'll just give you the hint. What is the question? You try by yourself. Find the magnetic field intensity at point due to a conductor carrying current of 24 amps along the z-axis extending from 0 to 6. So you can see, if I draw this, ये x-axis है, ये y-axis है, ये z-axis है. आपका conductor along z-axis है. Okay, something like this. ऐसे रखा है 0 to 6. So finite conductor है. Sin alpha 2, sin alpha 1, वो formula आपको use करना पड़ेगा. So it is kept like this. Point कहाँ पे होगा? 1.5, somewhere here. Y is 2, Z is 3. So somewhere here point P will come. यहाँ पे आपको H find करना. So how will you do this? I'll just extend this a little bit. Okay. If this is your conductor, extend this line. This is your reference line. So ये नीचे है. This is your alpha 1. So अगर ये point ऊपर आएगा, alpha 2. Alpha 1 negative होगा, alpha 2 positive होगा. If you just take this line, ये point क्या होगा? It is nothing but, what is the Z value here? Given 3. So this point, जब आप extend करते हो, it is 0, 0, 3. Okay. So दो triangles available हैं आपके पास. उस triangle से taking the tan value, base by opposite by base, calculate alpha and 1 and alpha 2 and use this formula H equals to I by I think it is 2 pi r, okay, 2 pi rho sin alpha 2 minus sin alpha 1. Okay, so using this, important यहाँ पे ये है, आप locate करेंगे कंडक्टर को, alpha 1 व alpha 2 कौन सा positive है, negative है, find the values and this will be in A5 direction. So hopefully you will try this problem. In the next class, we will continue the problems on the third concept. That is, ये आपका Ampere's law हो गया, Biot's law हो गया. Now we'll go for Curl, Stokes theorem and what? The scalar and vector magnetic potentials. That is, del cross A equals to B. Important concept है, इसके ऊपर problems हैं. Okay, this is the last part. इस पे आप हम problems देखेंगे in the next class. Thank you so much for joining everybody.